You are welcome to this channel. Today we shall continue the series of teaching on alkanols. In the previous videos, we have looked at the classification of alkanols based on the number of alkyl groups attached to the hydroxy-carbon atom in their molecules. And I said we have three classes of alkanols based on that condition, which are primary alkanols, secondary alkanols, and tertiary alkanols. In that previous video, we've been able to look at the primary alkanols, the description of primary alkanols, what primary alkanols are, and we have also considered examples. In this video, we are going to move to the next class of alkanols, which are secondary alkanols. We want to see how we can identify secondary alkanols based on the number of alkyl groups attached to the hydroxy-carbon atoms in their molecules. So what are secondary alkanols? Secondary alkanols, they are alkanols that contain two same or different alkyl groups. Two same or different alkyl groups. Alkyl groups which I can represent as R1 and R2. They are alkyl groups which may be either the same or different. So they contain two alkyl groups, same or different, that are attached to the hydroxy-carbon, attached to the hydroxy-carbon, hydroxy-carbon, to the hydroxy-carbon atoms, in their molecules. That is what secondary alkanols are. They are alkanols that contain either the same or different alkyl groups attached to the hydroxy-carbon atoms in their molecules. I hope you still remember what hydroxy-carbon atoms are. In the previous video, I explained that hydroxy-carbon atom is a carbon atom in the carbon chain that bears the hydroxy group. Is a carbon atom that the hydroxy group is attached to or covalently bonded to in the molecule. So secondary alkanols contain two alkyl groups which are either the same or different attached to the hydroxy-carbon atom in their molecules. Also, secondary alkanols, they are alkanols in which the hydroxy group, that's the OH, the hydroxy group is attached or bonded to a non-terminal carbon atom, in their molecule, which is also known as a secondary carbon in the carbon chain. That's another thing we can say about secondary alkanols. They contain hydroxy group bonded to a non-terminal carbon atom in their molecule. This non-terminal carbon atom is also known as secondary carbon. When you talk of non-carbon atom in a carbon chain, it is a carbon atom between the terminal carbon atoms in a carbon chain. The terminal carbon atom, like I explained in the previous video, are the carbon atoms at the ends of the carbon chain, which include the first, and the last carbon atoms in a chain of carbon atoms in a molecule. So the other carbon atoms in between these terminal carbon atoms are referred to as non-terminal carbon atoms. So when hydroxy group is attached to a non-carbon atom in the chain, and this carbon atom that bears the hydroxy group, when it is attached to two alkyl groups, then it is representing a secondary alkanol. Let me try to illustrate these statements with this structure. Take for example, this is a carbon chain. This is a carbon chain of 3 carbon atoms that are joined together by a single covalent bond, and you now have the hydroxy group on this middle carbon atom. The middle carbon atom is the hydroxy group, and you have hydrogen atoms to complete this molecular structure. You have this. The middle carbon atom, let me try to number them so that I can use the number to refer to the carbon atoms as I explained. Let's number them. The first one, the second one, and the third one. The first and the third carbon atoms in this carbon chain are terminal carbons, while the second carbon is the non-terminal. So we have only one carbon in between the terminal carbon, and that carbon atom, which is carbon number 2, is referred to as a non-terminal carbon atom. So when you have a hydroxy group attached to that carbon also is hydroxy carbon. Now if you look at the other two sides, the two sides of this hydroxy carbon or the non-terminal carbon, we have 2 alkyl groups. These alkyl groups, let's say this is R1, both of them are the same. They can be the same or different alkyl group, but this one contains the 2 alkyl groups which are the same. They are both methyl groups. It's a secondary alkanol because the hydroxy-carbon contains 2 alkyl groups attached to it in that molecule. So this is an example of a secondary alkanol. Don't forget, secondary alkanols, the alkanols that contain 2 alkyl groups, either the same or different, attached to the hydroxy-carbon atom in their molecules. And the hydroxy-carbon atom is a non-terminal carbon, which we can refer to as secondary carbon. If you look at the structure, that carbon is attached to 1 hydrogen atom and 2 alkyl groups, as well as the hydroxy group. So this is an illustration of what a secondary alkanol is. I can also represent the structure, the molecular structure, as follows. Can also represent this as follows: CH3, CH, and CH3. These are the alkyl groups. The CH3, these are the methyl group. They are the 2 alkyl groups attached to the non-terminal carbon that bears the hydroxy group. So this just to illustrate a secondary alkanol. What other things can we say about secondary alkanol? Secondary alkanols, they can be represented by a general formula, which is R1 CHOHR2. That's how we can identify them. They can be represented by the general formula R1CHOH in the middle, then R2. So this represents the general formula of secondary alkanols. I can also represent it as follows. Can represent it as follows. Don't forget that I said the two R's, R1 and R2, may be either the same or different. So this is an alkyl group. Now, from this general formula or structure, we can identify something at the middle. We can identify something at the middle, which is the CHOH at the middle. This is a group that we can use to easily identify a secondary alkanol. This CHOH group. CHOH group. So we can say that secondary alkanol, they can easily be identified. Don't forget, we are looking at how we can identify secondary alkanols. They can be easily identified by the presence of the CHOH group in the middle of the structure group in their molecular structures. They can easily be identified by this CHOH group in their molecular structures. That is what secondary alkanols consist of. They can be identified easily by the presence of the CHOH in the middle of their molecular structures. Let's try to look at examples of secondary alkanols. Let's look at the examples of secondary alkanols. Examples of secondary alkanols. Let's show them by structure. The simplest secondary alkanol is this. We have C, single bond C. This is the carbon chain. Then we have the OH on the non-terminal. The middle carbon atom is the non-terminal, while the other two carbon atoms are terminal. Don't forget that a secondary alkanol has the hydroxy group bonded to the non-terminal carbon atoms, which is usually in between the terminal carbons. So we have the OH in the middle, attached to the middle carbon atoms, and let's try to complete the structure. We have this. So this is, we can also represent that. As follows: CH3, CHOH, and CH3. The presence of this one is actually named as propan-2-or. Propan-2-or is a secondary alkanol. Don't forget that we have already come across propan-1-or as an example of primary alkanols in the previous video. Please kindly subscribe to my channel, share and like the videos, And don't forget to turn on the notification button so as to have access to more updates. So in the first video, we mentioned propan-1-ol as an example of a primary alkanol. And this one is a secondary alkanol, propan-2-ol, where the OH is attached to a non-carbon atom in the chain. So this is an example. And as you can see, we have the alkyl group as follows. These are the alkyl groups. There are two alkyl groups. Attached to the middle CHOH, the carbon atom bearing the hydroxy group. Let's look at another example. Another example of primary alkanols. Secondary alkanols. Let's look at this. This contains 4 carbon atoms. Now, the first and the last carbon atoms are terminal. Carbon 1, carbon 2, carbon 3, carbon 4. Carbon 1 and carbon 4, they are terminal carbon. While carbon 2 and 3, they are non-terminal carbon atoms. So if you have the hydroxy group attached to either carbon 2 or carbon 3, let me put it on carbon 2. If you have the hydroxy group on that carbon 2, and to complete the structure, you fill in the hydrogen atoms. As follows to have a complete structure. This represents a secondary alkanol. Why? Secondary alkanol because, as you can see, we have the CHOH. The CHOH in the middle of that structure. The CH, this is what we use to identify a secondary alkanol. So once you are able to cite this CHOH in the molecular structure of any alkanol, it means the alkanol is a secondary alkanol. It's a secondary alkanol. Then we have the alkyl groups. As follows. These are the alkyl groups. This alkyl group is a methyl group. This is a methyl group, and the other alkyl group is an ethyl group. So this is an example of a secondary alkanols that contain 2 different alkyl groups attached to the hydroxy-carbon atom in the middle of the structure. So what's the name of this secondary alkanol? This secondary alkanol is called, when you look at the structure, I'm going to teach you how to name alkanols. We are going to look at IUPAC naming of alkanols in the next video. Just stay tuned. Make sure you subscribe to the channel and turn on your notification button to have access to the remaining series of teachings on this alkanol. So by name, this is called butan-2-ol. Is a secondary alkanol. Why is it butan-2-ol? It has 4 carbon atoms altogether. That's butan. Then the hydroxy group is on the second carbon atom. The second carbon atom as numbered. So that's why it is butan-2-ol. Like I said, I'm going to teach you how to name alkanols in the next video. So these are examples of secondary alkanols. Don't forget, secondary alkanols are those group of alkanols that contain 2 alkyl groups which may be either the same or different, and they are attached to the hydroxy-carbon atom in their molecules. The hydroxy-carbon atom that is present in the molecule is a non-terminal carbon. That is the carbon atom found between the terminal carbon atoms in the chain. So it's a non-carbon atoms, and the alkanols, the secondary alkanols, can be represented by a general formula shown as above as follows: R1 CHOH, R to the R1 and the R2 are the alkyl groups, as you can see, and you can easily identify them by the presence of this CHOH. That's what we use to identify secondary alkanols, peculiar to secondary alkanols. So take note of this example, go through them. Make sure you subscribe to this channel, turn your notification bell on to always receive new updates as soon as possible in this channel. So stay tuned, we'll meet in the next video.